What's up, everybody? Welcome back. Today we are making a regex kernel module that's exposed to user space because I thought it would be fun. So, context is a few weeks back, there was like a pretty major computer outage where like a bunch of Windows PCs were blue screening because of this I think antivirus software or something. And it the root cause, it turns out, was that they were doing this regex compilation in the kernel, and they updated the list of regexes that they want to match against, and all of a sudden that exposed some edge case that just blew up their driver on initialization, and that caused massive outages. And I heard that and I thought that sounds fun. I want to make a regex kernel engine, regex engine in the kernel. So that's where we're at. The idea here is that I want to open a pseudo device handle. I want to write some stuff to it. I want to say set an ioctl on that thing, so I can say set some out of band data on this thing, so where I can say I want to use this thing with some regex, so I can say oh, there's start of line, hello, end of line, or something, right? Something like this. Then I want to say I want to write some stuff, goodbye, stuff, other stuff, and then I want to make sure that when I read back, essentially I only get the line that says hello. That's kind of what I want to do. We could do some extra stuff here, maybe we set a prefix and suffix so it can kind of show us exactly what was matched, and then we can do things maybe highlight the matched text in some funny color or something. So that's the plan. Where we're at right now is we have this kind of echo device set up. So if I go over here and I run a virtual machine that kind of loads our a stripped down kernel as well as our kernel module, I can see here I have our kernel module right here, as well as a test executable that was just the code of what I just had open on the screen. And if I do insmod dev regex, we have this thing now at dev regex here. And if I run our little test, he says the word hello, which is not really very interesting, except for the fact that we know that we compiled this test executable to write the word hello in and read something back. So right now, all it does, it just echoes everything that goes in, comes back out. And we need to update this to do regex stuff, So that's the plan. I don't really know how a regex engine works, so that's kind of the fun. That's kind of part of the reason why we're doing this. So we're hoping to kind of discover what a regex engine looks like by doing this. Okay, so step one is we need to basically try to set that filter pattern. Like we said, we wanted to call this ioctl, which means IO control, I think is what it stands for. And you can use that to kind of set out of band data on these pseudo device handles, right? Because the devices in dev, they have your typical open, read, write, but sometimes you need to set parameters on those things. So they have this extra command called ioctl, and we should start by trying to implement that. So we can go here. The way we've set this up is we wanted to work in Zig because it's fun, but the Zig in its current state, I could not get it to properly parse all of the kernel headers to give us the struct definitions that we need to set up callbacks with it says ask the Linux kernel, hey, could you give us this file so that with these function pointers that we'll call when somebody calls read and write. I couldn't get it to give us that nicely. I could have copy pasted some structs around, but I didn't really want to go through that effort. This seemed more reasonable. So instead we have a C file which kind of does the C glue, right? So he says stuff here are my operations, and please could you give me some character devices with these operations? And then we just kind of in these functions pipe the actual implementation into a Zig implementation. So we have regex impl.zig, who has read file and write file, who does some allocations and copy to and from users. Is this code committed anywhere? I'd be interested in seeing how much needs to be done to convert the glue to Zig. I completely get why you didn't, to be clear, just to make a reasonable choice. Yeah, sure. Yeah, it's, I think that the broken state is available here. But I think that I can try to make sure to update it soon. So I can kind of fill you in on the major problems here. I was trying to, I got it to the point where if I pre-process the kernel header with the makefile here, this doesn't have it. Fuck. But I had a setup where I was pre-processing a header file with Clang, with the C flags given to me by the kernel. And then I would run zig translate C on that preprocessed file, and it would segfault. I was going to compile zig and try to get a backtrace and file a bug report, but I just haven't got there yet. But yeah, so that's a clue. So like the kernel C flags are important, as well as I think that's it. If you just build a kernel module with the typical way of doing it, and then look at the C flags, pipe those into Clang preprocessor, and then try to translate C. That's the debug steps that I had. Anyways, let's make an ioctl. So here, I don't really know what this looks like. Ioctl, unlocked ioctl. So this takes in a file, an integer, and an unsigned long. I don't know what these things are yet, but we'll figure it out. So this is going to be regex ioctl is this. This is file. I don't know what these parameters are. So how can we figure that out? We can look for whoever uses this thing. I finally set up my indexer for the kernel, which is a really big win for us because holy crap, it was annoying to try to just find this stuff without it. So ioctl command to execute and then command specific argument. Okay, so we can take in a command and arg, and if I remember correctly, you need to like define these ioctls somewhere with this like ioc macro, if I remember correctly. Define new ioctl Linux. What's that thing above your head? It is a collaborative Rube Goldberg machine. So each of these chambers is defined by a WebAssembly module that defines all of like the rendering and physics for how like balls will interact. And people can upload WebAssembly modules at spheriphoria.dev, and then they get put part here. And it's kind of fun, a fun little thing. How do I define? I know that somewhere here the macros describing the structure live in ASM ioctl.h and are IO type number, IOR, IOW, IOWR. So this is like a read only, write only, or read write ioctl, I guess. They use size that says blah 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 blah. Okay, so can we go back to like, is this ASM generic ioctls? We were I feel like somewhere in the right area. It says ioctl.h. We need to go back to the Linux kernel folder, which is here. ioctl.h. IOC. This is not where I want. I'm just in somebody's implementation. But this is actually kind of fun because we can now see how somebody uses these things. So they create a magic where I guess like, I don't know who decides which magics are allowed, but so they have a magic 97 and they call IOR, IOW with this as well as the arguments that they're passing in. Okay. And then we can maybe see the definitions of these. And this doesn't really tell us much interesting. So the thing that I'm like mostly worried about is I want to make sure that like if we were to allocate a number to use as our magic, like is there rules? Ioctl magic number. Like how do I determine deciding an ioctl magic number? To decide a hex ioctl, to decode a hex ioctl code. Most architectures use this generic format, but check this for specifics. This guy just uses a fucking character. Read. Character R function. I guess there's no real risk of collision here, because if I collide with someone else, it actually doesn't really matter, right? Because we just have to not collide with anybody else who has the same operations for our device. So we'll just fucking make one up. We'll just make one up. That seems fine by me. So let's go back here and we'll just say that, where the fuck are we? Here. Our regex ioctl magic is just like, and here we say it was set regex is io, I guess, right with the magic. And we have to include Linux ASM. What was it? ASM ioctl.h? There we go. Here. And it was IOW type NR size. So here, do we just use like number 0 or something? What did that other guy do that we were looking at? I lost it. Here. No. We were in the Linux kernel, that's why. And we were looking for like IOR. Just somebody, give me an example, anybody. He just picks a number. Sure. So I guess for us, we can just kind of say that we have like 0. And fuck, I wanted to see the argument. So here, this is a type. So I guess we kind of have like a character pointer is what we want in here, right? I think. I'm confused. Why are you using C? We need to have some, because like the glue code for the kernel, it was just kind of hard to get it hooked up to the in Zig. So we have a little bit of C, but mostly Zig. The hard work is going to be in Zig, and the bindings to C are going to be here. So this is command, and this is arg. And then I guess, are we supposed to cast this? Who uses this? I'm gonna open a second shell here because we're gonna be referencing the real kernel enough that we are going to have to look at this a little bit. We might as well have a window open dedicated to looking at the kernel. So let's go in here and look for anybody who uses IOW. Okay, so like disk add, who calls this? Nobody? How does this get like set up? Oh, because this goes in bcachefs ioctl.h must be used in can we like look for references on this? LSP info? Oh, this isn't compiled in, so this is a bad example. But that's okay. bcache fs. Can we just like grep for this? Oopsies. How do I? No? Okay. We will copy this with my fingers and paste it. Here we go. So he switches on command and calls this thing. So he has an argument on here. Void star user. Oh, interesting. So he actually uses like a user pointer here. Even though it said that the command was unsigned long, I guess that this technically could be seen as a user pointer. Interesting, because I guess it's like kind of like the same size. And so he just switches on command, which seems reasonable. And I guess here we only have one command, so we'll just say like if command is not equal to regex set, we return something. Surely there's like no something. No TTY doesn't sound right to me, but like what are my other options? Where is this defined? Inval seems way more reasonable. So let's do that. This isn't supposed to have a semicolon. That makes sense. And then here we return 0, probably. Okay, so if we have this, now we're gonna have to get into the Zig side and do something with it. So I guess here we have like a user pointer. I guess we should consider it a user pointer. Like this, I think is what they did in the other side in this example. Void underscore user star. And then here we can do like a copy from user, or we can send it directly over to the other side as a user pointer. let's do that. So we'll say that we have some sort of like zig function that returns like an int64t, and it's dev regex impl, and what's he going to do? He is going to set regex. So he's going to take in the pointer to the file structure, as well as a user pointer to string data, which we will say just has to be null terminated, I guess. And he has to remember on his side that it's going to be a user pointer, but that's okay, we'll figure it out. So dev regex impl set regex. And we're going to pass in file private data. And arg, I guess. Sure. No previous prototype. Okay, that's fine. Don't care. Incompatible pointer types. Oh, that's interesting. So how does this guy solve the incompatible pointer type? Here he does a manual cast. I see. So we will just do that ourselves. So we will go back to doing unsigned long. And then here we just cast this to a const car star user arg or something. Which seems okay. Okay, so now let's go into the other side. And we have to like make that function. So that's this. Here. Oopsies. What have I done? Here. Paste. So pub export function. This. He returns an i64. He has his file comes in as a star file, and his data comes in as a star u8. And I guess that's fine. Here we need to... Well, that's kind of interesting. So we actually, this seems like invalid, because how are we supposed to copy from user? Like in kernel space, you're not supposed to like dereference the user pointer. But if we're working with like a null terminated string, how are you supposed to get that thing out without reading it, right? Is there like a copy from user, like null terminated? Copy from user string. Like, okay, so yeah, here he's asking like the same fucking thing. And he just said, pass in a length. That seems reasonable. That does seem reasonable. In which case, for our ioctl scenario, that kind of means that we need like a length field to be passed in as a we need like a fat struct to come in here, right? A little fat struct boy. Shut the fuck up. But here we're gonna say like regex struct regex set arg. And here I'll have like data. Like this. And with a ph, of course. Yeah, fat as in cool. And here we'll have length as a size t length, I guess. And then I assume that we have to like double copy from user here. That would be my assumption. So this is now going to turn into a struct regex set arg. Does that mean I'm supposed to put user here? Probably. So here, if we have, I assume that like this gets this user thing gets compiled out, like the preprocessor doesn't use it if we don't have the kernel define set. Else he defines this BTF tag type nothing. Yeah. So this goes away in most cases and is just like an extra annotation for us. So it's probably okay to write this here. Probably. And then what? What? Also, is this in the right spot? Is it supposed to go, the user's supposed to go left or right of the star? I feel like right of the star, to be honest. He's mad about something. What if I take this user thing out? Incompatible pointer types. Oh, because I'm not allowed to use this array list. Okay, fine. So we'll have this gets like arg. This turns into the struct regex set args user pointer star is equal to arg. So this needs a name, so we'll call this set arg. Then here we'll pass in regex set arg data and regex set arg len. But we're not actually allowed to do this yet. So this needs to be a copy from user to this thing. Yeah. So this is like this. Copy from user into regex set arg from arg length size of struct regex set arg. That seems right to me. To from unsigned long. So here we need to cast this probably to like a struct regex set arg user star would be my guess. And this can fail. So what happens? What is this supposed to return? Copy from user return. What does it return? I guess anything non-zero. If what is this? Long? Unsigned long, yeah. If is not equal to 0, I guess we just fucking send it back. I don't know what the fuck I'm talking about. That seems reasonable. Too many arguments to function. That's true, because this now needs like a better thing here. So this gets size t as well. Then on the zig side, oopsies. Then on the zig side, we have data len. Much better, much better. Okay, so now let's just try to print it out, right? If we can print it, that means we've done something somewhat sane. So here we'll say discard file, and we're gonna like create a kernel buffer that is len size. So buff is like this catch panic boom. We are going to copy what is it? Regex dev regex copy from user the data into buff pointer at len amount. And then we should be able to do like print k a string. I guess we want like alloc this plus 1 so that we can set buff len to 0. I guess we need to defer kernel free of buff. And then we copy the thing in from user space, and then we should be able to say got regex request for this. And we have to be careful here, but we pass in buff pointer like this, I think. So if we did everything right, we should compile this, and it should compile. It won't, because it never does. But if it compiles, then we should see, when we ioctl that thing, a nice little log. No such file or directory. Yeah, that's true. So I kind of changed the testing environment yesterday, so I think this goes here is where I'm supposed to make it from. Much better. And then bad copy 2 is called at inline from regex ioctl, copy from user, bad copy to copy destination size too small. What a fucking nice little thing of him to say to me. That's actually so sick. Okay, so why? 2, unsigned long. How is this not oh. Double pointer. We fucked up. We fucked up. It's a hard life out here. So now value of U64 ignored. So that's in the zig side over here. Let's just do this for now because we're fucking lazy pieces of shit. Here, I guess we do need to return something. So we'll return a 0 to indicate success. And it looks like it compiled. Looks like it compiled. There's some relocation errors, but we'll ignore those. And I think that I can do, this is like a new script, so I'm not positive of this, but I think we can do dir dot slash dev regex co and dot slash test. And I think that does not look like it's doing what I want it to do. So here I need to make sure our run script should go to scriptster should be like dir name, kind of this. This is scripter, and this should be the real path of Puad. Yeah, that seems right. That seems right. So kind of files are relative to where we ran the script from, but then we go to the scripter. So this goes scriptster like this. And push d scriptster pop d. Okay, let's also then just kind of do this just to make sure that we can run.sh. So we copy from here, but we go into the RAM disk. Hell yes. So copy, make our RAM disk, run qemu, and we should be chilling. We should be chilling. So here, if we, I guess we don't really have our test case set up because we have to set up the user space, which we didn't do. Every time I run this script, it like just totally fucks up my terminal. I think that qemu is doing something fucking annoying. But here in our test.c, let's do ioctl on this file descriptor, set regex, or what is it? Dev regex set regex or something, and we set it with the arguments. So we actually need to like put that definition of the argument stuff in some header somewhere, I guess, right? That makes sense to me. Right? So like kind of all of, hello? Where's the, oh, here. This stuff needs to go into like dev regex ioctl.h or something, which means that we need to like include asm ioctl.h here. And probably, where does size t come from? Like a unit, I don't know. Size tc, I don't remember where it comes from. Std.lib, std.def. Std.def sounds right, but surely that's not where it goes in the kernel. Is it like here? No. No. Linux. It could be in like somewhere like just deep in here. Yeah, this is a little sketchy. A little sketchy. This feels wrong to me. But I guess we'll find out. So then in our this side, we need to include dev.regex.ioctl.h. I guess there's somewhere we have an example of somebody else exporting this shit, right? So we should leverage that. So this guy had bcachefs ioctl, which pulls in asm ioctl. And he just uses underscore underscore U32. Okay. I guess maybe that is reasonable for us to do as well. So here we should be like underscore underscore U64 or something. And then we don't need std_def. Unknown type name, fix available. I mean, it's auto-completing, which makes me think he's saying include ASM generic int LO64. I mean, it looks like I don't need to do that unless it's like kind of through Linux UUID. Stood arg, no. Or no, std_def. Linux std_def? No. For size t. Linux types. That sounds right. There we go. All right, let's try that. Let's try that. So on this side, let's kind of include that thing first because that will kind of indicate to us if we really fucked up or not. And let's call make and just see does our thing build? It looks like yes. Looks like it built. And then we can go into our test binary. And now we can also include dev regex ioctl. And then we can call ioctl with fd and dev regex. I already forgot everything. I forgot everything. It's regex. These should be dev regex, but it's fine. Regex ioctl. We'll say regex set. And we pass in the arg as a pointer, I guess, which means that we need struct regex set arg equals. I don't remember how to do this in C. Is it like this? I actually can't remember. We have an example here where we set the file operations. Yeah, it is like that. All right. Len. I guess we'll set it to like hello or something. Data is equal to hello. Len is equal to 5. And where does ioctl come from? Man to ioctl. Assist ioctl. All right. So if we've done everything right, we should be able to compile gcc-o test.c with static. He's mad because there's no field name len. That's fucking weird. What do you mean there's no field name len? Error. Oh, maybe he's mad at the user pointer thing? All right. It's fine by me. There we go. So that works. And then now we run again. Okay. Then we insmod dev regex.co. And then we run test. We segfault. Good. So interesting. Interesting. Now, how do we debug this? I guess it's likely related to here. So let's start just with a print k and say like, hi mom, ioctl here reporting for duty. And then on the Zig side here, I guess here we will also say like we got the arg. And then maybe here we print out at least the len. Right, let's start there. This is LLU, I guess. And then on the Zig side, can we do something like copying from user before we copied from user. Copied string from user. All right, let's just kind of see where it's a disaster and where it's not. Reset because my terminal's broken. And let's run it again. Insmod dev regex. No. Insmod dev regex test. So ioctl here, reporting for duty. We got the arg. and then protect and fault. I wonder if surely copy from user doesn't like recurse, right? That's like not possible. But we could at least start here with like allocating, copying to from size. Yeah, it seems fine. Sorry, I'm thinking for a second. Copy from user. Yeah, I mean, that's how we're using it over here. Copy from user. We get a pointer from user space of U8, and we copy it into our output buffer. So I don't see any problem with that. I don't see any problem with that, but we shall see. And then actually, let's set up a little init script here because I'm tired of typing the same thing. So bin sh, we can do something like insmod dev regex co, and then we do like test, right? That's all we're doing, I think. All right, and then we can go back over here and we can go run, please. Okay. Attempted to kill init. Right, cause what? In our init script, we need to exec bash after. I think, if I remember correctly. Let's see what that does. Okay. Why is this just working now? Oh, because we didn't. Oh. No, I'm confused. We didn't mount dev tempfs, but then how is anything ever happening before? I guess it must. No, I'm confused. I'm actually quite confused. But that's okay. That's okay. We will just go back here and mount dev t dev tempfs on dev, and here we will actually run /test just to make sure, and we will try again. No, what the fuck? There, this is the one. Nice. There we go. There's our seg fault, baby. So here he's saying allocating, and he actually is crashing on allocation. Interesting. Interesting. That is not what I would have expected, actually. Unless it's here. It could be here as well. So let's put allocated here. Make. Run. Ah, so he did allocate. Oh no, allocating. Here. Immediate crash. I kind of feel like it makes sense to try to set up GDB in some way. I know it's possible. There's a way to like debug. I think you just like in QEMU, just write -s or something. And then I run it GDB on the kernel. This sounds right so far. How do I make sure that like kernel modules are loaded and stuff as well? I guess we'll find out. I guess we'll start there and we'll kind of work our way forwards. So let's I think it's here. Make menu config. And let's enable debug. Debug info. Here. Debug info. This is selected by debug info Dorf toolchain default. So somewhere around here. Debug info. Yeah, let's select this. Okay, and now is it set? Debug info? That sure is set. Big win for us. So let's remake the kernel. Let's remake the kernel really quick with some debug info. Hell yeah. And I guess another terminal. GDB. Yeah, let's get GDB ready to go over here. And I think that then we just like GDB with the VM Linux output. I think is what they said. And you say like, I want to do like remote debugging. So I think QEMU, when you launch it, like knows where in the kernel he's executing and loads like kind of like embeds like a GDB server in himself. And then your GDB just has to be like, oh, okay, I want to set a breakpoint on like this address. And QEMU is like, yeah, I know where that address is. Like it's like mapped, but like we can find it. And so I think that when we segfault, we should be able to get like some sort of useful information, but we'll see. We'll see. We will see. So QEMU, my kernel, my terminal's fucked again. So I think it was like -s or something. We could actually look instead of just guessing. QEMU system x86-64. It's like -s. Man QEMU -s. Whitespace -s. Whitespace -s whitespace. There we go. Do not start system. So capital S is pause and lowercase s is GDB. Which I guess kind of makes sense. We do kind of want that. So can we like nvim our here we change this to say -s. Then we go back to running our run script. And so nothing's happening, which makes sense. So now in here, we should be able to do GDB VM Linux and target remote localhost 1234. And then we hit continue and we start seeing stuff happen. And then he segfaults, but we don't see that happen. If I break here, we do see that like we are in the kernel. And if I go here now, nothing's interacting. I hit continue, and now we do see something. So we need to find, we need to probably breakpoint at wherever this like fucking like bug shit happens. So we can look for like general protection fault in the kernel and try to set a breakpoint there. I think that makes sense. Or maybe like, oops. Die looks promising. This is oops %s sig. Is that what that said here? He said oops, maybe for address. Can we look for that? Ah, here, this is where we want to break. So this is traps.c line 687. Traps.c 687. So can we GDB on output Linux, VM Linux, breakpoint here? Hell yeah. Okay, now we were just going to run this again. Target remote local host 1234, continue. Oh, it's so fucking sick, man. So sick. Okay, so now the problem is that our backtrace gets broken when it hits our kernel module. So there's a way to fix this. GDB Linux LKM. Loadable kernel module. Okay, so where do they talk about like loading the module? Make scripts, blah 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 blah. LX symbols. Ah, this looks promising. Examples of using Linux Pro. So here, I want to build scripts and LX symbols. Like, how do I get that? That must come from, like, these scripts. So I need to, like, get VM Linux gdb.py from somewhere. I don't really understand this, but if I do, like, you know, /output Linux, like, of course, like, why would it auto, like, there's a load step that I'm missing here. You know? What happened the last thing you were working on? New project? We're just taking a small break. Small break. Okay, I want, like, GDB KO symbols. Like, some, just GDB Linux. Like, I just want, like, a little bit more hand holding. But this is just the same fucking thing again with different formatting. Surely I just have to, like, load some sort of script from somewhere. Or it's possible that when they were talking about how I need to do config GDB scripts, then maybe, like, it embeds something in VM Linux itself that tells it to load that. That seems crazy to me, but it doesn't seem like impossible. Okay, let's try it. Let's see what happens when we do that. Let's see what happens. Make menu config. GDB scripts, he's saying. Compile time. All right. Let's see what happens. That seems crazy to me, but I mean, it's not impossible. Like, why else would it be part of kconfig instead of, like, this extra thing? Right, so here he symlinked all of these things somewhere, which is interesting. Yeah, he does this. Oh, maybe if you see, like, executable dash thing, maybe that does something. That's kind of interesting. That's kind of interesting for sure. So let's go back here. And he is complaining about, like, auto loading. Yeah. Nice. Okay, so now we can just say, like, load this. How do I, like, source, I think, maybe? Maybe Python? Maybe I need to be in that directory, which is a little annoying. GDB VM Linux. Source VM Linux GDB. Yeah, there we go. That seems to work. All right. So now what? Now we just try to reproduce the problem again. So we need to set the same breakpoint, which I think we had here. Nope, we lost it. That's super fucking cool. So I just need another window here to go back to Linux. Oi, Nixshell. What a pain in my ass. And like, it was in, like, trap.c, probably. Shit. Trap.c, and it was like, oops. Maybe address was what we searched. Traps.c, it was right here. Here. And then we ran qemu with our run script. And then we hit target remote localhost 134, continue. We backtrace now, and LX, here we go, baby. So this is what we're talking about. It was we now have access to this, like, LX symbols. No module object found for devregex. Fuck. We didn't rebuild devregex after we did, after we enabled GDB, so it's possible that we have to kind of rebuild it so that it knows how to do the debugging stuff. That's not impossible. it's also possible that we might have to like copy the kernel object somewhere. We'll see. Let's run again. Quit. Yes. GDB. I didn't actually want to do that. So it was source VM Linux GDB, and then it was breakpoint over here, and then target remote localhost 124. Continue. Okay. LX. What was it? LX symbols? Yeah, no module object found. Ooh. Warning. This has been, auto loading has been declined. Can we just do set auto load safe path? Fuck, what did I just do? Oh god, oh god. Oh, it doesn't say scanning for modules here. So could we maybe like copy the module over from like driver dev regex co? Can we copy this here and just kind of see what happens? So source VM Linux GDB break here. We run again. Thanks for the prime. Have I written a Windows driver before? No. For some reason, you remind me of Chef John. I don't know who that is. All right. Target remote localhost 124. Continue. Backtrace. LX symbols. Oh, here we go. So now it has symbols, but this stuff is still fucked. So that's kind of unfortunate. I was kind of hoping that we would get something a little bit more interesting here. It does also look like, by the way, this is just like a broken function pointer. Which is a little annoying. If we hit continue here, though, we get a backtrace over here. So can we like breakpoint on this and like just fucking run it again? Like if I run like test again, it's just broken. So no luck there. And I don't also know if these are like the same consistently. Yeah, it's annoying. It's interesting to me that like, oh no, it did work. It did work. Hold on. We just have to hit continue in the other window. God damn it. There's just so much going on. Target, remote, localhost, 134. LX symbols. Can't access memory, so here continue. Here he didn't break. Why? Quit. We'll just restart. We restart everything. Restart everything. Restart everything. GDB VM Linux. Continue. Source. The fucking VM Linux GDB Python file. We breakpoint at this location. We hit continue. Program's not being run. Target. Remote localhost 124. We continue. Okay. LX symbols. Okay. And how do we like... LX ls mod. Okay, so this is doing something. And we continue here. And can we do something like breakpoint here? Or something? Breakpoint here. Can we have breakpoint at like address like this? I mean, we can try it. We can try it. Test. Continue. Okay. So this doesn't help me either, to be honest. That's kind of funny. What if we breakpoint like higher up the stack, like over here? Because we know that our kernel module is loaded at A0000. So this is probably where I want a breakpoint. This is kind of like related to that address. 255, sure, thanks to the prime. We could try breaking it here. Del 2, del 1. And because the seg fault doesn't actually stop us from hitting this again. But it does not look like breakpointing on this worked for us, which is unfortunate. What if I breakpoint here, right? Like, let's just like start hucking shit around. Dev regex interface.c line 74. That's a good sign. That's a really good sign. But the breakpoint is not triggering for some fucking reason. Can we like, we can, but now that we know we can break on like dev regex interface, can we look at what's in there? Like, what if I just go in here and I'm like, can I break on like dev regex ioctl? Can I like b regex ioctl? Continue. Like, okay, that's good. So now we can kind of walk through this. Okay, this is looking pretty helpful. Dev regex impulse set regex. Jump in here. Data is totally fucked. No, okay, that's not fucked. I don't know why this is complaining. Or this, like, both of these are sane. And then this crashes. Fuck. We go again. We're getting close. We're getting so close. Next. Step. Next. I guess here we actually want to break on the allocate, probably. We don't know. So we go in here. Next. Step. Next. Probably here. Step. Next. List? Like, what's going on here? Next. Step. Next. Raw alloc. Oh. We stepped here and it broke. Why? I'm confused. I'm actually so confused, but that's okay, because I'm having fun. So it must be like in the allocator, right? It must be like here. Can we breakpoint here? That seems to work. So what happens if we run again? Continue. Test. Continue. Okay. So here we are asking for a pointer of length 8. Here we are now in the ioctl, and we continue, and he segfaults before even getting to the allocate, which is very strange. Which kind of lines up with what we saw in GDB just now. Right? It does kind of line up with that. That, like, the allocator interface is, like, doing an alloc with size and alignment. Alloc bytes with alignment. I can't remember. We got to like here, this raw alloc here, I think, is where we saw it crash. Test again. Continue. Yeah, okay. So here we are about to crash. And can we just like step here? Immediately fucking trap. Right? So what's going on there? What is going on? Like, he's not even getting into raw alloc. He's not getting into our allocation callback. It's just like something in here is just fucking us. Unless the GDB stuff is not right. So alignment is a comp time. I guess, is it possible that like self is broken here? Right, we're not even getting into the function call because he's just trying to look at invalid memory. Seems not impossible. Seems not impossible. First rule of GDB is that it's never GDB. I mean, I've had GDB screw me many times because like the dwarf info just wasn't quite right, and so you kind of draw incorrect conclusions. Okay, let's look at p self. It does kind of seem like that would do it, huh? Oh no, self is a pointer 0 vtable, but that's fine because raw alloc doesn't use pointer because it's unused. So can we look at p self vtable? Yeah, this seems okay. This seems okay. Nobody's ever dereferencing self pointer. P return address, p alignment. Alignment is comp time. So log2a comp time is also comp time, probably. Right here. So it's just very confusing. Like, how are we not making it here? Right? Like, what? What? What is going on? What is going on? Have you ever used GUI GDB? I've used it in the past. Well, I've used some GDB GUIs, and they always fuck me because I have a lot of history using like, kind of like slow remote boards and stuff, where like, GDB GUIs will often do things like say, every time you step, could you please list all the variables and registers? And like, sometimes that gets in the way and just like slows stuff down to the point where it's like unbearable. So I've just kind of stopped using them and got kind of used to the command line. Can we look at like what is at here? Like, what is this? Oops. Not really, huh? Can we make it so that like our call trace shows symbol names? There must be some sort of config for that. Linux kernel debug call trace. Like surely if we like menu config that, that will help us. Maybe I don't fucking know, man. It's just we gotta progress somehow. Also depends on if you're relying on the JTAG interface and boundary scan because that will always be slow forcing a lock step. Yeah. That's the type of shit. For me, it was not that. It was like network GDB, just like over TCP, but it was still bad enough that it was a problem. I think maybe there was like, you know, big locals and you just like freeze up, and it's just annoying when you're trying like you're in this like state where you have like a rarely reproduced thing and like GDB just like bones you. It's just annoying. So like trace, maybe call trace, syscall trace points. Where's there like, is there like debug kernel hacking? Probably debug x86 debugging, debug kernel, stack backtrace support. Looks like what I want, to be honest. Looks like what I want. Make J5. But yeah, I can see why people could easily look at me debugging and be like, "What the fuck are you doing, you troglodyte?" Like, is that a bad word? I assume it's not a bad word, but I should be careful. What does this mean? Yeah, that seems fine. Nobody's gonna get offended about that. Like, only trogs think that. Yeah. Sorry to all troglodytes. But yeah, I can see why people would be like, "What the fuck are you doing?" But like, it's also that I started using some pretty advanced features of GDB as a result of that. Like, calling them advanced is like insane. But like, you know, stuff like dprintf, where you can say like, make this breakpoint, and instead of actually breaking, do like a printf formatted string and stuff. And so like, I spent a while looking for GUIs that had like command line support, and those were like pretty far between. So I don't know. It's like I just don't mind using the command line interface at this point. You know? I probably have to rebuild this as well. Probably. And now can I run our little run script again and see if this gives us more information? Target remote, continue, continue, disable BR, continue. So do I get like a nice little like, I still don't get like names here. Linux kernel function names in call trace. Like, what am I missing? Right, so this is what I'm used to seeing. But surely there's just like some missing config that's set. Call kernel kernel call trace missing symbol names. Debug flags. Compile the kernel with debug info. I did do that. Fine. I guess we'll just do this again. Because I don't understand why, like, when I did, like, this before, where I break on the place where it's dump stacking, I didn't get, like, a nice backtrace. Right? We had, like... He just kind of, like, dies here. But, like, this backtrace is, like, totally fine. Right? Like, here he gets to... OA. Oh, this isn't even like the right spot. But like here, can we like break on this address? Which is not, I'm confused. I'm confused. Oh. ChatGPT, that's not crazy. That's not crazy. It does seem like the type of thing that he might be able to help me with. How do I copy? My Linux kernel backtraces look like this. Am I missing some kernel config, question mark? Yeah, I mean, these definitely look relevant. This definitely looks relevant. Dude, I mean, I will say, however much I shit on ChatGPT, I mean, we're yet to see if this solves my problem, but you know, he's not always so awful, you know. Debugfs is not helpful here. He's a fucking idiot, but sometimes he's not. Frame pointer does seem like also kind of nice. I'd be down for some frame pointers. What the fuck? Frame pointer. Why is that not set? Depends on debug, kernel, and Arch want frame pointers. Oh, which I guess x86 doesn't want. All right. Fine. Fine. It's like an intern with a stupid amount of knowledge. Yeah, it is a lot like that, right? It's like not that interns can't think, but like, it's like somebody who's like really bad at critical thinking, but just has so much knowledge available to them. Down a frame pointer, if you know what I mean. It's so fucking stupid. So stupid. But yeah, I bet you this will help. We'll see though. We can dream. Because I think that if I remember correctly, that k-allsims, it's like you could tell that the debug symbols were available in the binary because when we type GDB, we like have that information. But I think k-allsim says like, yo, like we can actually see those symbols from like within the kernel itself. It's like part of our executable instead of just part of like the debug info, if that makes sense. That's not very clear because the debug info is like kind of party very executable, but you know what I mean. If I remember correctly, you can actually look at like proc k all sims, right? And this will show you names and stuff, which is kind of fun. What was I doing here? Del br and target remote. We probably need a new kernel. We need to reload GDB because it is a new kernel. GDB VM Linux. And I probably should recompile my kernel module itself as well, right? Because it's probably depending on the kernel configuration, and so it probably makes sense for us to, you know, get the latest and greatest. And then here, I guess that means we also have to copy the latest and greatest here, so that when we run GDB and then we source, okay, you know what? We're gonna do run.gdb because this is getting crazy. Source VM Linux GDB py. I guess it's not getting that crazy. Target remote localhost 154. And then here we want to say file VM Linux. Yeah. gdb-x run.gdb. And then continue. Continue. There we go. Does he have... Oh, there we go. Here we go. So it actually looks like alloc bytes with alignment goes then into set regex. Like, what is going on here, do you think? What do you think is going on here? Where we have like set regex, alloc, set regex, alloc, set regex. Like, what the fuck? And all of these with like the same offsets? Where like something about this seems wrong, you know? Also, how come we lost the addresses now? That's also kind of funny. We used to have addresses and now we don't. Alloc bytes with alignment anon. With size alignment, with alignment. This must be some sort of like inlining shit. Right? This must be something inline. Alloc bytes with alignment. So I mean, we really haven't like learned much, huh? We've kind of just seen that like it sure is in that allocation. Very strange. Very strange. So can we do like, you know, let's just start trying to bisect a little more. We're gonna take a little bit of a different approach, just to see. I assume that this will also segfault, and then I also want to disable GDB for now. So let's just do fuck off GDB. Run. So yeah, that does still segfault. And does this stuff tell us anything? Maybe for address this. Maybe this is something that we should look at. Right? What lives here? So we could maybe go back to let's go back. Let's go back to running in GDB, which was we did this. Make. Here we did copy the kernel module over here. Here we look at the qemu. Fuck, man. Test kernel env run GDB, run.sh. Let's go back to turning on GDB here. Run.sh. Fuck. Right, of course, this isn't the right fucking run.sh, not run GDB. I'm so confused. There's so much going on. This is run.gdb here. Continue. Okay. He crashes. we pause LX symbols to get it to load the regex kernel module, and then can we just say like, what the fuck is at this address that it's complaining about? Right? Like, what is here? How do I know? We could try to see if this is like, oh, this is just what it thinks the stack pointer is. Right? This is stack pointer. Stack pointer? Stack pointer? Okay, wait. That's a good clue, actually. Might be a good idea to objump -t. But I think that like the reason I was doing it this way was because I didn't like the way that the kernel modules are like dynamically loaded, so we don't really know what their addresses are going to be. But LX symbols might help us a little bit. LX, what was it? LX symbols, like, just, what the fuck? What were the other options in here? LX, LS mod. The fact that it's RSP is stack pointer, right? No, I guess. Well, he's saying general purpose. RSP does kind of look like stack pointer, according to that. What is like a stack pointer register x86? ESP, and RSP is the 64-bit version, I think. RBP is frame pointer, RSP is stack pointer, right? Snapshots, yeah. Okay, so if we're getting a general protection fault here, and FC08. Oh, this is FC98. I was a little bit off. 0008, FB98 to FC08. So we are incrementing the stack pointer by some small amount and trying to use it. I wonder if we just have like, if our stack is just too small? Surely not. Alec bytes with alignment. Set regex. Because here it is kind of saying that like, if our existing stack pointer is at B and then we're going to C, we're like going up and then getting out of our stack. Right? That's what this could mean. I wonder how we can test that. Make menu config. Stack. Debug stack usage. Seems interesting. Debug stack overflow. Memory debugging. Where was the stack overflow thing? This was debug stack overflow, debug kernel Y, have debug stack overflow. Ah, I see. Don't have that. Damn. But memory debugging does seem maybe useful. Memory initialization. I want to see if I can like change the stack size. Kernel hacking. I mean, we might as well take a little peek. We might as well take a peek to see if that's like changeable. I guess we could look, maybe the easiest way to get at this would maybe look at config and look for stack size. Nothing in here seems... Doesn't really seem like that's changeable. I want to know, like, can we... like my suspicion is Stack Overflow. How do I tell? Linux kernel Stack Overflow. Like Linux kernel module RSP protection fault. I don't know. This isn't gonna help me because everybody Googling this is just gonna be seeing shit in D-message. ChatGPT? Maybe? We can tell them what we're seeing. Right? We can tell them. We can tell them like, hey, what the fuck is going on here? What if our memory allocated to this virtual machine is just like nothing? That's a possibility. I'm seeing while writing a kernel driver. It looks to me like we are running out of stack space. RSP is very close to the fault. How do I know? How can I debug if this is true? Question mark. Okay, fuck off. What a fucking arrogant piece of shit, this guy. Dude, I'm like, I've got a bug, and he's like, you could look at the fucking code. How fucking stupid do you think I am? Okay, this is what I'm asking, and then this is what I'm asking you, right? He's like, examine the kernel stack size. That's what I want to know. Config stack size doesn't fucking exist. Right? So he's just a fucking lying piece of shit. Oh, I hate look, use GDB. Oh, can you imagine? Can you imagine like how far gone you'd have to be writing a kernel driver and then ask him like, yo, I'm lost, and he's like, try looking at the logs? Like, I guess then again, the amount of people that I've worked with that ask me what's wrong, and I'm like, read the logs, and then we read the logs and they say exactly what's wrong. It's just dude, come on. What a stupid thing to say to me. I just have to be so far fucking gone to not be able to to not come up with look at the code. Right? Like it's just insane. It's just insane. Okay. I mean, this is fucking what a fucking like piece of shit. Have you thought of using your eyes? Yeah. Oh my god. Okay, it's fine. I mean, it's just like, what did I expect, right? It's like I keep surprising. Like, I should never expect anything but this, because this is what happens like every time. I guess every once in a while I use it. I'm like, hey, you know what? That was kind of nice, like the K all sims thing earlier. But it's just, I should never expect this to not suck, right? Like, I just shouldn't expect. It's just. Okay, let's just double check. Let's make sure that he's a lying piece of shit. He's like saying like change the stack size, which is exactly what I was trying to do, by the way. But like, right, that variable just doesn't exist. Maybe it did at some point, right? Maybe he's just working off old info. Okay, so what we could do though is we could try checking our stack pointer. We might be able to try like looking at the stack pointer as we go up the stack and seeing how much we've used. Alignment does not seem crazy. Might be worth looking at the doesn't label function and check for alignment. Although everything is like align cast, and I would think that general protection fault is not an alignment issue, but it could be. It could be. What's bothering me here is that like it's not complaining about like allocated memory. Like, we're not even getting to the allocated memory. That's what's bothering me, right? Like when we were in GDB, it's not like we were like stepping into allocate and then crashing, right? We actually never made it to this KZ alloc, right? Which would make way more sense to me, right? If we like allocated some memory and then we like referenced it, right? If it was like crashing like here, right? After we allocate the memory, we try to write to it, and like the alignment is fucked up or something. That would make sense to me. But that's like not what's happening, right? We stepped into this function to the point where we got to this raw alloc, and it didn't even enter the function, right? And so like that lines up with the idea that the stack is running out of room, right? Seeing that like RSP variable and then it crashing, saying the address that is like where the stack pointer would increment to, all of that lines up. All of that lines up. So I want to keep pulling on that thread a little bit. So maybe we like, I want to see like at where's the top of our stack when we enter the function, and that might be able to give us a clue. What's your mem allocator impl? It's pretty dumb. It's pretty dumb, and I don't know if it's right. But we can show you, just since you asked. Alloc, we call dev regex alloc, and free, we actually do nothing. Which actually, you know what, might be a fucking problem. We could actually call free, maybe. That's a good idea. And then these are just bound into C functions that just wrap k free and kz alloc. That was kind of the intent. Like, you know, we just did like the stupidest fucking thing we could do. I doubt that that's it, but you know, I think that this kind of lines up, the stack thing kind of lines up with some stuff we saw yesterday too, where we were how do I say this? This lines up with some of the stuff we were seeing yesterday where I think we hit the same problem and then it just like kind of went away and we didn't really understand why. If it was like stack smashing shit, then it could just be that like we recompiled and like it fixed itself. You know? We could also try building in release mode and see like if we did like optimize release small or something, and we just get like totally different behavior. Then like me. Just check what's print k, is that the raw kernel function? Yeah, it's just like the kernel printf implementation. Right, so if we do release small and our stack gets way smaller because like our like the amount of function calls that we do kind of decreases, maybe that could like have some effect. Might as well take a try. Might as well take a try. The stack trace showing multiple copies of the allocator internals is really sus. It really reads like the allocator is recursing somehow, and it shouldn't be. That was my read on it too, and my guess there was kind of that it was like maybe there's just some sort of confusion around like where things were happening. Like if there's, yeah, just my gut was a confusion, but you are kind of right. Like this print k here does seem kind of, it seems sus that we're going like print k into dev regex info. Like this whole stack trace seems kind of fucked up. Looks like an open and shut stack overflow. Yeah, I guess if we're just recursing like idiots and then stack overflowing because of that, could be. My gut says that the stack trace is broken though, right? Like how are we going into set regex, then into print k, then from print k back into set regex? It could be just like stack corruption. Oh, you know what? If we call print k with the wrong fucking arguments, could that like fuck us in some way? It would only read invalid memory, not write, right? Because like print k knows which arguments were passed to it based off of the number, like the format string. Oh yeah, that could fuck up your stack, huh? Because like print k would assume it would be like a variable argument thing, right? And he would look at like, you passed me a double, and he would like allocate space on the stack for that. You'd paste it in, but then he would never free more space than he got, unless like the calling convention is that externally you push in, and then internally he pops, and he just like doesn't correctly like put the stack back to where it was supposed to be. That seems like not impossible. I don't really know the calling convention well enough to make that call, but it doesn't seem crazy, especially if we're seeing print K in the backtrace. I would be curious. Okay, that's like on the list of things to be worried about for sure. Let's run this test though, where we compiled in release mode just to see if the behavior is different. Because I just want to know. But then that's like print K is really feeling like somewhere to look at. So here it looks like we've kind of like inlined all of the allocator stuff, and we don't see any printf in the backtrace, which is kind of interesting. Yeah, see, VARGs is a goddamn nightmare, and getting it wrong can do tricky things. Now this is looking like a more sane, to some extent, backtrace. Can we like just like print, like, can we just like print the stack variable in like, I guess I would have to do like an ASM trick to get the stack pointer out, huh? Like, unless there's like Clang built in like stack pointer address, like, can I like get that? Print out value stack pointer. P equals null. Oh yeah, that's not okay. Fucking course. I'm a fucking dumbass. Fucking dumbass. Okay, I want to see what happens at entry and at exit. So when we come into like ioctl here, can we be like, stack pointer is like this, with P, and we take the address of val, and then we have like val is equal 0, int val is equal 0, right? And then we do this again down in like, I guess we kind of have to do it at, well, we know if we do it on entry, then we can look at the logged failure and see how far apart they are. So here we go. Fucking lose my mind. Why is it doing that? What the fuck is pointer val? Like, what the fuck is that? Pointer val. See %px below. Unmodified. Yeah, of course I want that. Of course I want that. Although this is making me think that there's maybe something about the kernel memory model that I don't understand, and maybe this won't be like a good. Okay. Oh, also, why isn't it fucking broken anymore? You guys notice that it's not fucking crashing? What the fuck just happened? Am I fucking stupid? Like, what do we what? What do we change? I should have git committed when it was broken so that it was easy to reproduce. Okay, no, it's okay, it's okay. So we're back. It does seem like just some sort of like random stack corruption, huh? It does seem like very much like that, like all we did was add that print. Which is kind of interesting. Okay, so I do like the idea of being very careful about our print case. So I'm just going to go down, but it's just so hard because if we change print case and it like changes the stack setup, then it's just so hard to know if that's the mistake. Allocating, allocated. See, in here, there's not like anything crazy, like up until the point where it breaks. There's really nothing crazy. Oh, it's so annoying. Let's go back to the makefile and go back to debug mode. Ugh, love this, huh? We're back? Hell yeah, we're back, baby. Okay, let's get @u, get commit-m, and say segfault, baby. And then we can start kind of poking a little bit. So we saw that we did this. Int val equals 0, and then print k %px stack pointer at this. And that like changed behavior. Right? Right? Could it be release mode? It could be related. Although we also had it not working in release mode as well. So I don't think that's definitely it, but I think it could be like it definitely could be related. Okay, so here in debug mode, we added that print, and then it fixed itself, kind of. I don't know what the fuck this is, which is a little scary, but otherwise it seems like maybe fine. At the very least, that allocation is fine. So is it just that the variable itself was enough to fix this? It is. Oh no, it's not. It's not. So it's the print itself here is changing it. Although maybe like val is getting optimized out, so it's kind of hard to say. This is fun. This is fun. So there's like it just feels like it has to be stack corruption, right? What if our like call our what if we fucked up our inputs and outputs here in a way where it like just like fucks us up? Could we maybe... You know what? We did also see in GDB, all of the arguments were like fucked as well, right? I'm pretty sure we saw that like when we first saw info args, they all had the wrong values. That sounds familiar. This is a classic alignment issue of some form, given it's not an instruction fault. If you're running in 64 mode, it turns out the default assumption is a 16-point align stack, not 4-byte for 32-bit. I mean, but like both sides have been compiled in x86-64, right? So I don't really see why that would be a problem. That value we also saw showed 24 bytes on the fault address, but that would be fine if it was like 4 8-byte things being pushed, right? Could it be caught from user? I mean, I don't think so. Right? We're like the fault itself is happening in the allocation, right? So like in the stack towards allocating, we haven't done a copy from user at that point, right? Like it seems like, yeah, it just feels. Well, I don't know, because it also feels like if it's working sometimes, then like it can't be that we're like running out of stack space, right? Because we saw that our stack entry point is like quite close. So it's not like we're going like kilobytes and kilobytes down the stack, right? Here we start at 8E4, not 908FE4, whatever. Not that we can guarantee that it's the same, but given that we're seeing like, you know, C900 8FB98, 8FE84, it's not like we're like going like super far down. It's like a few bits down. I guess I don't know what a general protection fault is, which could be really like changing my interpretation of this. Which is why like you talking about alignment does make sense. Which is kind of why I'm wondering if like if we fuck up our argument passing, maybe like the assumption on one side is that the stack pointer is aligned to some point, but when we push our arguments, we push different arguments in, and so that says that like the protection fault is actually when it's spilled over into a region that's configured as not configured as writable. But like, are we like hitting a page boundary here then? That doesn't make sense to me. I guess FC, what is like, if we look at B to C, COO, that's 3072. Doesn't feel like a page boundary, right? Like our pages should be like 4096 would be my guess. So like it doesn't make sense to me that this is like a new different page from here, you know? Doesn't feel right. General, like I just want to make sure that I understand like general protection fault. As in we were in like traps.c. If hint is not equal to GFP no hint, we print this. So this is coming from X general protection. Oh, and this is like a signal. This is like the CPU is like flagging some event, right? Right, that explains why we're in traps.c. So here we have the x86 trap general protection, and that sends us over to the general protection fault. Andy, thanks for the tier 1. Much appreciated. Oh, ads. Sorry, man. I see. So here we need to know what triggers x86 trap GP. And we need like, I guess that comes from like the fucking Intel, that like massive Intel page, probably. But it would be nice if like, you can have bus faults for other reasons, but those would come in on like, I thought that those would be different exceptions. It would be nice to like see general protection. So this is, yeah, straight from the CPU. So can we look at like x86, like interrupt 13? No, we want like general protection fault. Like, can we just like get like a fucking, I just want like a list of things that can cause this. Is a fault type initiated by ISA-defined protection mechanisms in response to an access violation caused by some run code? I mean, it's very possible that like we're compiling our Zig code with like some stupid fucking arguments. Wait, I think I figured your issue out. He's gonna, I'm gonna, okay, well, my guess is that my Zig compiler, my Zig compilation is just doing something fucking brain dead. That's my guess. Also, you might be working off some, oh, you think you were wrong? Okay. May also classify some exceptions, access violations. Okay. Some operating systems may also classify some exceptions not related to access, such as illegal opcodes, as general protection faults, even though they have nothing to do with memory protection. So how do I determine that? There's attempting to execute bytes in memory which are not instructions. Okay, attempting to read, yeah, that makes sense. Other miscellaneous conflicts. If you're sussing the zigzag logic, you can push a branch on and check it. I do, yeah, you know what? Why not? This is kind of the benefit of being a streamer. Is that I can just be like, anybody want to look at my code and fix for me? But we might as well. Get, no? Do I not? Get push. What did I do last time? I just pushed directly here. Oh, get push. That's the wrong one. Dev get push. This one. Okay. Yeah, so my biggest suspicion in here is that something in here is fucking stupid, and like I'm like not compiling in a way that's like compatible with the existing Linux kernel or something. So there's a chance that like this build.tig is just like fucking stupid. If you want to double check it, I'll take it. I want to keep looking at reading about general protection faults. So how I guess like this guy's saying that like operating systems may classify illegal opcodes here. How could they do that? They would have to like configure the CPU to do such a thing, or they could like they could like throw the interrupt themselves. If I remember correctly, you can software interrupt or hardware interrupt. And I don't know if we know where it's coming from. Right? Can we like look for x86 trap GP? X86 trap GP. What CPU are you emulating? I'm emulating. That's a good point as well. I am just running QEMU system x86-64 with no kind of like intentional arguments. Which, who knows what that does? I don't. Like, CPU options. Like, what is that? What am I allowed to do in here? So it should be the same as host. I don't know if that's true. I remember that you have to pass host somewhere. QEMU system x86. Like, can we look at like can we look for CPU host? I remember seeing that around. And it could be that like my compilation is assuming something. Why don't I have QEMU system? QEMU system x86-64 help. Like I remember seeing like host. I remember being like, hey, could you please like say that I have all of these same CPU? Yeah, it's dash CPU host maybe is what I'm looking for. This sounds familiar to me. It sounds familiar. Run.sh. I mean, I don't really believe that this should matter. CPU host requires KVM. So here I think that we just say like enable KVM or something. Or maybe it's just KVM. Nope. Enable KVM? Run? Okay, so that's still the same shit. So that's good. I mean, I didn't really expect that to be it, to be honest. Yeah, I think the critical thing here is to understand how this is getting triggered. But the fact that we're in the kernel, and we are seeing just between a single step in GDB a general protection fault, my gut says the CPU is flagging it. Can we ask QEMU log in like protection fault? You know, like it feels to me like QEMU must know that it's doing something, and I want to see if we can like get that information out. QEMU log protection fault address or something. Like, is this like something we can do? Page fault and general protection fault. Is the blah 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 QEMU. Logging options like dint. Oh, let's fucking go, baby. That sounds sick. What's -d? Enable logging of specified items. Oh yeah. Show interrupt inside. Yeah. -d int. Let's just fucking. What happens? You know, what does he have to say to us? Nothing. Oh, no. This is. How do I see like QEMU logs? Logging and debugging info can create a log, or you can access monitor SDIO. So if I do like monitor stdio. Did that do it? Can't use stdio. I see. He's complaining. So can we do like -d log.text? We need a big D, not just a little d. Okay, and so if we like cat log text, nothing. Oh, there's a log.txt here, but nothing came out of it. It will enable debugging. This is useful if you have QEMU source code and want to see detailed debugs. For example, passing will enable CPU log reset will show CPU state before CPU resets. These are written to temp QEMU.log by default. Okay, so let's turn off D. Not that I think that this will change anything, but I just want to say cat ls fuck ls-l temp QEMU log. Nothing. He's a fucking liar. Oh, but I turned off -d, I think. Did I? I don't remember. No, it's still there. -d int. Okay. I mean, we're kind of going down this like kind of incorrect rabbit hole, I feel like. I feel like we should be focusing on the error itself. Oh, but I wanted to understand if the general protection fault means what I think it means, right? That's what we were originally trying to figure out. So we were looking at this. So read only, attempting to execute bytes, version of design instructions. That's not what we're seeing probably, I don't think. Attempting to read. This feels like writing and reading incorrect portions of memory seem reasonable. Can we look at the memory maps? Can we look at like which fuck my brain. So when we were working on that operating system like a year ago, I remember looking at this like something page table, GP paging. Can we look at like a OS dev like hello world or something? It's getting started. I remember this thing where you tell the CPU what your what pages are allowed to be, like you set up the way that it fucking when it says like, yo bitch, you can't write here. I remember that being tied to some table that you set up somewhere and you have to do that like really early in like the entire process. Somewhere around here. Bootloader, stack, call kernel main. No, I remember like it was really important. And so I'm trying to think like, can we log that thing and see like if the hardware thinks that the page is like not allowed to be written to. General descriptor table. Thank you. That's what I was looking for. Can we like Linux, like OS dev GDT? This is what I was thinking of. I don't know if this is really relevant. Global descriptor table. This is ringing a bell. There might be an internal print earlier on the kernel. Initial printout. Yeah, that's kind of what I'm wondering. Is like, can we log segments? And I don't remember if I remember. It's possible that this is not the way that people do this anymore. This might be implemented by paging. Where I seem to remember reading something that's like, eventually you just like you end up just setting this thing full writable and you handle it in the page table. Linux, can we like log writable pages? Like it feels like something like proc mem info feels like it feels like there's something there. Because I just want to know, like, all I want to know is, am I supposed to be allowed to write that piece of memory? Right, that's kind of all I want to know. What's that, ChatGPT? I'm getting general protection faults in a Linux kernel driver, and I am trying to bisect the problem. I am unsure if it is faulting because it has tried to write an invalid memory address. How can I print which pages are readable? Can I query if a page is mapped read, write, or not? Using Linux or hierarchical, you can check the protection flags on the entry. So is page writable? This doesn't seem crazy, to be honest. This doesn't seem crazy. I mean, we have to check, right? But what is current? I doubt current. Like, where does this come from? Let's see like if he's like totally out to lunch or kind of out to lunch. So can we look at like LSP workspace? Can we look for like PT right? Okay. Hold on. It's not crazy. This is definitely not crazy. And here, how does he get this stuff? ptep get from ptep, where ptep is follow pt? I mean, this doesn't seem crazy. Look up a pt at a user virtual address. But we need to have this like arena, which comes from somewhere. Is there like, do you want to go crazy? QEMU can log everything. I'm down. If QEMU can log, I'm down to see it. But when I tried to log earlier, it didn't give me what I wanted. But maybe like I didn't check like log level. Maybe. Yeah, because here I did look at dash D. I did turn on dint, but yeah, I don't know. Okay, so looking at this like memory address stuff, it would be nice if we could figure out how to like just go from like fucking memory address to page and like look it up. But I suspect that that's not going to be super trivial actually. It's also funny to me that like just like very slight function call adjustments, right? Like the real trick where we fixed it by changing the stack size feels really, it just feels fucked up to me. Okay, can we at the very least, I just want to like double check all of my function signatures, right? Like, we know that that's like an error, like error prone, and we might as well just be sure. We might as well be sure. So let's just walk them slowly. We'll walk them slowly. So dev regex alloc. This returns a void star, i.e. any opaque. Wait a second. In your build zig, change your target query string to freestanding GNU. I'm not sure if it's defaulting to the correct API. Dude, thank God. Okay. That's a very, very helpful thing for you to say to me. That's very helpful and seems very possible that it's wrong. I am down. I'm down to try that. Somebody linked a log thing for QEMU. I'm gonna look in a second. So that is still kind of equally incorrect, which is good for us. I guess let's just make sure, that we are compiling what we think we're compiling. So hi, hello from Zig, just to really make sure. Ron.sh. And we can look for hi, hello from Zig. Okay, so we are running what we think we're running, which is good. But it does not look like that was it, which would have been really funny. Also, how old is your Zig version? I think it's 0.13. Zig version 0.13. Yeah, so I think latest stable. I think. All right. Let's go. I'm gonna go back to analyze, just triple checking, or maybe single checking. Maybe this is the first time I've looked. So this takes in a usize, size t. It's possible that size t and usize aren't lining up, but I suspect that that's not the case. Any opaque, void star. Realloc. We actually aren't using realloc, so let's just get rid of that guy. Free. Returns void, takes a void star. Returns void, takes a void star. Great. Copy from user, void star, usize, u64. Copy from usize, copy from user, void star, usize, u64. And the same for copy 2, void star, usize, u64. Void star, usize, 64. All right. So then impl init. Okay, yeah, going the other way. Okay, so this is sketchy as fuck, right? Let's just throw that out there. He says that he returned something, but he doesn't know, so let's fix that. All right, well, we've already found one problem. Dinit, void, okay. Alloc file. Returns, void star, takes nothing. Okay, we're chilling there. Write file, void star, car star, size t. So pointer, size t, and u64. Write file. Pointer, size u64. Pretty sure that is fine. Read is pointer, usize, u64. Pointer, usize, u64. So we're chilling there as well. Set regex. Pointer, usize, i64. Pointer, usize, i64. So I think all of those are okay. Feels okay to me. That's kind of like both sides of the thing, but the fact that our init was fucking up our stack, not that I think it should really matter, because if we were getting past init, then we were getting past init, but we could check. Maybe there's kind of unexpected behavior. Nope, so still broken. But it was worth looking over. RAX 87C D8. Okay. I mean, so yeah, we're seeing a lot of stuff kind of just looking at nearby pointers. I guess we could maybe infer that the way it's failing, because it's calling self dot raw alloc, and that's where we're crashing, that the self is probably a pointer to the allocator. We can probably guess that we are looking at an offset into the allocator. I'd be kind of curious to look at that a little closer again. So can we turn back on GDB here? Oh, I wanted to look at apologize for ignoring your log messages. But I might go back to that. I might. But I kind of want to pull on this thread a little bit. Okay. So let's run GDB. And let's go back here and copy the kernel module here. And then we GDB-X and hit continue. We LX, what was it? LX symbols to get everything. Oh, source. What? No, it was symbols to get everything loaded in. And then we can try to breakpoint on the line that we thought was broken. So that was in here somewhere. Driver dimple zig. And we got into this allocation and we made it all the way to raw alloc. This is where we think is broken. So here we breakpoint here. We continue, run our test again, and we hit next. That was fine. Right, because this function allocates multiple times. So we need to only think we're in a problem when we're in the ioctl syscall. So this is here. This is where we think it fails. So can we p self here? We are at CD8. Okay. So let's think about that a little bit. Step. Okay, perfect. Seg fault. And the seg fault was at, or seg fault's maybe the wrong word. General protection fault. C08. So this is like kind of far back, or far. Oh, stack pointer go down. Stack pointer go down, man. So this is actually trying to reference something that's up the stack. That makes sense. So maybe we can, okay, first let's see if this is reproducible. Can we like disable BR? I want to see if the memory address that it logs is consistent. C08. C08. Okay, so that's really good. So we can actually just try to figure out what's at C08. Yes. Okay. So disable BR and breakpoint on dev regex impl set regex. And we're just looking for whatever the fuck is at C08. PQ system, thanks for the tier 1. Thank you. Thank you. Test. Okay. So can we, first of all, can we like next? Can we like, what's on the stack right now? Right? Like print and len. This is E38. So this is pretty far up still. We see numbers are going down, and the thing that we're seeing at C08. So we can step into this and we can see like what's at alloc. Oh, because the first one is in the it's a global, I think. Okay, D30. We're looking for C08, so we can go a little farther down the stack still. Okay. Info locals. Can we p like and n return address? Still can go a little farther down. N CBO, we're getting close. CB8. Okay. We don't need to be here. S. Down here. Okay. So this is where we think the problem is, right? Like, can we look at like self CD8? Where is our crash at? C08. So numbers are getting smaller and we're still not there unless, can we look at like byte count? BFO. Okay, yeah. So in the allocator field here, we must be seeing a problem here. So we can look at like allocator, vtable, CEO. This is confusing. What is like the size of an allocator? This is just a pointer and a vtable pointer. So sorry, we're stuck. We're confused. C08, 87C08. So that is how many bytes past E0? Wait, before E0? Hold on. p byte count b. Return address bf8. So these are going up as we go farther along the arguments. But self is cd8. So they're not really in like a well-defined order, I guess. Lug, I fixed that already, but thank you. Yeah, I saw that. Thank you. I mean, yeah, I did. That was one of those ones where I was like, maybe, but probably not. Like, what if we look at like p self vtable dot alloc, right? So these are nowhere near, because the vtable is living in like static memory, right? So there's something going on here. Like, we just have to find who would want to look at C08, right? And we know that it's like related to this, right? So it has to be one of these things. Well, I guess it could be that the stack pointer info registers. Where is the stack pointer right now? The stack pointer right now is at B98. So the stack has already passed the bad point, right? So something above us right now on the stack is causing the problem. We are trying to access it, and we must be trying to access it as part of this alignment, right? It feels like it's like alignment, right? Because like we're before well, log2a alignment is like, that's a comp time value, right? So it feels like that shouldn't be it. Can you make GDB do a memory access to trigger the fault since the trap? I don't think so, because GDB is kind of like talking to QEMU, which kind of has like free reign on all memory. But we could maybe look at what value is stored at that address to see if that gives us a clue. Right? I bet you that I can just like fucking like, we can probably like p this and like, you know, as like a int, right? Like we can like look at it, but it doesn't really help us necessarily. Maybe if we look at this as like a uint64. Does that look familiar? That's maybe like a pointer to another thing on the stack a little farther up. Interesting. Okay. Up. Info args. P self. D. We're looking for C08. Remember. C08. CBO. CB8. Okay, so these are going up. We are, where are we? Frame 1. So we go into alloc bytes with alignment, down. Are there like things, are there like local variables to look at here? Info locals. Byte pointer. C60. Info locals. P byte count. CD0. Okay, so yeah, stack go down number now, man. That makes sense. And it just feels like none of, and our stack pointer has, we saw in the registers, has already passed C08. And we're only 16 bytes past C08. Right? That's what we're seeing here? 98, no, wait, hexadecimal. Python 3. C08 minus B98, 112 bytes. Oh, we're way past. Stack pointer only gets decremented in frames, if you recall correctly. Oh, Then maybe I'm just like a fucking idiot. Then maybe I'm a fucking idiot. Can we like disassemble? Can we like step instructions? Just, AB. Oh, interesting. So we were at here. So what does this say? This says like from the base pointer of this frame, we want to put stuff here and here. I see. Okay. Okay. Move APS. So is it possible? Is it possible that if we are doing it, if we are crashing here, wait, it was at we were at AB, right? We were at AB. So that's this. So I don't know which way this goes, but we can probably assume that we're taking the register value in XMM0 and trying to put it into this position, right? So is it possible, whoever was talking about alignment earlier, it doesn't seem crazy if this is not aligned correctly for XMM0. What is XMM0? Like what is XMM0? What is this? XMM is a vector register. That sounds right. So like a floating point 32, which might need 4-byte alignment. And he's saying like, bitch, you're trying to access memory at C08. C08 seems like 4-byte aligned, right? Yeah, it is. 8/4 is 2. So it seems like that should be fine. Even if it was 8-byte aligned, that would still be fine, right? I think. Linux doesn't support floats in the kernel by default, if you recall correctly. Does it support vector instructions? I mean, we've been seeing like there's other. Maybe there's not other XML. I mean, the Linux kernel doesn't support floats, but like the assembly should be fine. You can use the registers intermediate variables. Yeah, that sounds right to me. Right? There's nothing like stopping. I don't think there's anything in the kernel stopping you from like touching that register. And we know that we're not really like there's no floats here, right? We're using like byte count, like alignment is a U29, return address is a usize, right? So there's no like float usage going on here. It's possibly just using it. Move APS must be aligned to 16 bytes. Oh, that's a good clue. That's a good fucking clue. Moves 4 or 16, blah, 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 blah. Align. Move aligned. How do I know? How do you know what the alignment? Oh, yeah. Okay. Which indicates, assuming that Zig is doing the right thing, right? Hand wavy. That means that someone is moving the stack by 8 bytes by mistake, right? If the assumption from Zig here is that we are like 16 byte aligned at this point, then RBP must just be not 16 byte aligned if we understand this correctly. So here we're seeing RBP at 7.8, right? So RBP at 7.8 is violating the constraints of this move APS because he's moving to an 8-byte aligned, like an 8-byte offset. And that could also explain why when we put that int on the stack earlier, it fixed it. Right? Because then all of a sudden, the alignment changes. Yeah. Okay. So then the question becomes, who's fucking us? And again, it just feels like a C-Zig boundary's gotta be at play here, right? How does Zig know when he calls this his alignment? Do the exported function pointers? I guess he doesn't know like the stack. He can't know the stack alignment. Right? Like the stack pointer could be anything, but you could maybe assume that it has to be some value. Dude, is it gonna be something fucking stupid like a size t isn't a u size? is that gonna be it? Because we are just kind of using size t's here. Unsigned long, kernel u long t. Unsigned long has gotta be u64, right? Right? It's gotta be. Size t is not strictly the same, but are equivalent on any same platform, including x64. I guess like assuming that we're using like the real signed t or size t, right? But we're using some sort of kernel defined one. But this looks like what I want, right? All 64-bit architectures use unsigned long size t, and unsigned long on x64 has to be 64 bits, right? Unsigned long. Oh, this is just minimum. I guess we would have to check this with like unsigned long x equals 4 print the number of size of x, right? Like something like this. And then return 0. And then LU, and then gcc-show test. 8, yeah, 8 bytes. So seems pretty fucking reasonable. Seems fucking reasonable. I thought long is 32 bits and long 64. I think it could be 32 bits. Could be, but not guaranteed. I don't know if this is related, but have you fixed the license string to end with a null byte? I would be shocked. Absolutely fucking mind blown, like understanding of the world completely fucking gone. If that was the problem. Also, I think that strings in Zig are null terminated by default, right? But here we could manually specify the type as like, how do you do this? U80 like this, just to be sure. What is it? How do am I fucking mental? 0. No, this is this has to be a buffer directly. I see. I guess maybe like the dereference thing isn't automatically, but I'd be absolutely shocked because like that has nothing to do with the stack, right? We have just decided that the problem is that our stack is not 16-byte aligned, and so this just being in static memory somewhere has nothing to do with that. I would like, does Lug, if you're still around, oh, you are. You just said something. Do you know if there are like rules about like what Zig expects the stack to be like in like exported functions like this? Like, I assume that the C calling convention defines something. I just don't really know what. Like GNU calling convention. Like is it expecting that like when I call this that the stack pointer is aligned in some way? Because it seems, I guess it also could be that print k. So Zig should not be expecting anything other than sysv calling convention. Oh, nice. Sorry, I missed that message earlier. That seems very nice. So 3.2.2 you said. 322 defines stack requirements. Stack grows, blah, blah, blah. The stack needs to be 16 or 64 byte aligned immediately before the call instruction is executed. Once control has been transferred to... What if the fucking return value of print k isn't what I think it is? What if this is wrong? Then it would be if even multiples of print k would solve the problem. Which would explain why the print k worked before. Oh, fuck me. Fuck me up the ass. Because we just copied this from somebody else and we never checked it. Print k goes to print k index wrap, goes to print k index emit, p func. So we in print k deferred returns an int. I mean, which technically, like, this should be fine. Like, if we were like C int here, I expect that nothing will change. I suspect. But I mean, we could just be like very fucking sure by running it. I don't think that should matter. Like, if this changes anything, I'm gonna like lose my fucking mind. Wrong button. Run.sh. We want this run.sh. Nope, we don't want to edit it. We want to run it. What is happening? Oh. Run.sh. And I don't want to run in GDB right now, because I think we've like kind of like hard diagnosed the problem at this point. I'm pretty confident. Run.sh. No fucking way. Okay, we're gonna go back just to make sure. So we're gonna change this C int to I32. Oh no, he's back to working. Wait. Get diff. We have... What the fuck? Was it this? I'm pretty sure we tested with this at some point. Right? Is it that some of my stuff isn't committed? Yeah, I'm actually kind of confused. I'm actually very confused. Why isn't it broken anymore? What the fuck? What the fuck just happened? No. Okay, check out this. Make. Right, we know we committed when it was fucked. So please God, be fuck my life. Fuck my life. I don't understand. Wait. Does test.c, this is still, oh, never mind. I forgot that I changed test.c. Thank God, everything makes sense again. Makes sense again. We just weren't running the test we thought we were. We need to rerun GCC. Right. Okay. Holy shit, I was about to lose my fucking mind. Okay, we're back to seg faulting. Hell yeah, baby. Like we expected. Now we can go back to that test where I don't think this will change anything. First of all, we need to fix this. We already fixed this int return. Right, very important. Very important indeed. Not that I think it is actually very important for this, but we have to make sure. And then we wanted to change this to say cint instead of either 2, which again, I don't think should matter. I don't think should matter. But, you know, we might as well just check, just in case. Okay, good. We're still crashing. Not strictly an alias. Cint is not equals to either 2 for reasons, but exact same in memory layout and size and everything. Gotcha. Okay. So, good. We're back to crashing. So, okay, because I would have, like, lost my fucking mind. Okay, let's, now, just trying to see what happens if I, like, put one more print k there. Right? Just to see. Okay. Interesting. So that doesn't do jack shit. But we did see, let's just go like double check our known fix case, right? Our known fix was we wrote int val equals 0, print k percent %px of val, right? We know that this was a fix at some point. Let's see if that is still a fix. Yes, that is still a fix. So like this lines up with our current understanding that like we need to push the stack forward. So, like, I bet you if we did a U64 here, it doesn't fix it. That would be my guess with my current understanding. No, that's still, oh, interesting. That's interesting. I would have expected that doesn't change, that stays broken. Because I would have thought that a U64 would push us forward by the same amount. Oh, unless the 64... the U64 on the stack there might force an alignment that I didn't want. Is it possible that this is getting called with the wrong things? No, we checked this, right? Set regex. So the calling convention here says that we need to be 16-byte aligned. The fact that RBP was ever not 16-byte aligned seems like a problem, right? Because that's, I think, is the base pointer and the stack pointer different? I thought the base pointer was like the previous stack pointer. I'm not 100% sure on that. But it would be maybe interesting to just kind of breakpoint here and look at the values of the registers as we kind of go down the stack. So let's go back to run.sh and turn back on kernel debugging here. Oops, we need to go back to in our C file here. Let's undo that thing on the stack. We did. Maybe we didn't type make. There we go. And I thought, did we not just turn on debugging? I thought we did, but I guess we didn't. All right. Let's go back here and copy the kernel module and then run.sh, run.gdb, break on dev regex impl set regex. Not defined. Right. We need to crash once to we need to get the module loaded so that this thing knows to load it. So we hit continue here. Then we breakpoint and say lx symbols. Then we can breakpoint here. Nice. And then we hit continue. And then we run our thing again. He crashes again. Well, he went out yet. But let's look at like info registers. So RSP. Right, like, we're already fucked here. Right? Right, according to this, that says that the stack goes downwards, the end of the input area must be aligned with a 16-byte boundary. In other words, the stack needs to be 16-byte aligned immediately before the call execution is instructed. So, like, this already seems broken, right? Am I crazy? If we go up... Oh, yeah, I mean, the fact that when we go up... Right, like, this is fucked. Right, like, we're already fucking boned here. Okay, so we can breakpoint at a dev regex ioctl. What is it called? Dev regex interface. It's dev regex interface. Dev regex. Oh, it's just called regex ioctl. Run that motherfucker. Oh no, continue. Sorry, we don't want to run it. We want to continue. Okay, so info registers. RSP, nice little 0 at the end here. Next. So let's see if right before our fucking call. Whoa, what the fuck just happened there? What the fuck was that? Look at it. What like we just kind of just jumped from line 183. Okay, so 64. 18 to 64. From here, we just went out to like the fucking nether. Like, what the fuck just happened? Like, seriously, what the fuck? This is interesting. Can we breakpoint? I want to breakpoint here. And just kind of like continue and like fucking run it again. Okay. So here, debug info, totally fucked up, right? That's fine. But what I'm more interested in here is my stack pointer fucked here? He's fucked here before the function call, which really makes it feel like something in the C side is actually fucked. And I'm not gonna lie, this feels kind of like it might be a little sketchy. Can we breakpoint at 66? Can we breakpoint at dev regex interface C 66? Del 3, del 2, del 1. Like, fuck everything else. Let's just fucking info registers. So here it's also fucked. Already, actually. Well, I guess, like, fucked might be strong. Can we go, like, 64? I guess it's possible that, like, the stack pointer, when we call, it might actually, like, maybe it's supposed to pad itself a little bit before. No, the fact that it's jumping to thinking that it's in class create, something about this is just, like, totally fucked up. Right? Like, it's just something's wrong. Okay, continue. Okay, 62, we're lined up. Lined up, baby. P info registers. Here, our stack pointer is not, base pointer is 0 line, stack pointer is not. So I wonder if that's like just kind of normal. I don't know. I don't know yet. Mug, what did you mean by getting fucked by the red zone? I kind of assumed that you were going to keep going there, but then I don't see anything from you. But I was kind of hoping that you would say more. What kind of projects do you work on in the past? You have so much knowledge and low level. I mean, we wrote an operating system when we first started the stream. That was the first project we worked on. So we've kind of been in the sauce before. In your build.zig, do red zone false and mno red zone. And add mno red zone. So the C source is just compiled by the Linux kernel itself. So the Linux kernel has like rules for it's like %.o from %.c. %.o from %.c. It's probably this. Let's see. None of these look like the one I'm looking for, to be honest. Can we for like C flags? Who is responsible for this? It's over here somewhere. What the fuck? Am I in the wrong folder? I could be that it's only in like the built version of these. No. It's alright. It's okay. Just the kernel will do the right thing. It's fine. Just do build zig one. I'm down to try it, but do you mind explaining a little bit why? What is it? What is it? I guess I will look it up in a second. I'm down to just try it. You should keep it. It's very important when doing anything in kernel land. I did just kind of not try anything. Like I just got I did just like type randomly until things ran. You know, so I don't really know what the fuck I'm doing. So target remote localhost. Oh, oops. Let's go. Yeah. Target remote localhost 1234. What's going on here? Can we just nbim run test kernel run, like fuck this GDB shit. It's just too much. It's just more to deal with right now. Run. So that does still seg fault. Typing random things until it works. Don't know why it always works for you, but not for me. Yeah, sorry, man. I would be interested to see if we do like this. And we kind of like zero this out. Oh, that's kind of maybe a bad, can we do like len equals 6? And like data equals hello or something. But I just kind of want to see if this copy from user is like fucking with us, you know? That's still seg fault. So it can't, the copy from user cannot be the problem. So that's interesting. So basically, the SysV API defines a small zone below stack pointer called the red zone, which leaf functions can use without touching the stack pointer. However, in kernel land, that's really bad because interrupt handlers don't respect it. So you can clobber stack memory, so it needs to be disabled in all kernel code. Ah, okay. I think that I had in my build zig. I don't have it here. I had somewhere like code model kernel, which we kind of lost. But you're kind of pointing me. That's a good point that like things seem like they depend on that. So I think I lost this by mistake when we migrated from building object on the command line to a build.zig. And you saying that just kind of points me to like, you know what? Shit might be fucked. Still fucked though. So that's good, I guess, by some metric of good. By some metric of good. Fuck. Oh, I'm so short on time. Oh, I want to keep going so bad. I'm so like, oh, the address of the fault change though. It is still like the same thing though, where it's like just aligned, 8 bytes, and it is still in this like regex alloc thing. God, I want to keep going. Dev regex impl. Oh, my editor's fucked. What is happening? Reset. Code model isn't strictly necessary. We set pick. Okay, that's good to know. Okay. So this guy takes in a car star size T. I wonder if this like user thing does something fucked up and I didn't know. I thought it might be just like a flag for the kernel, like a preprocessor flag. But I wonder if it actually does something. No, I mean, at least it's not doing anything like noticeable here. This is fun. So int64 void star. Okay, let's can we simplify this a little bit to kind of like just kind of get rid of this print. What is happening here? Is my thing fucked up again? Reset. App driver interface.c. Okay, so this is what I wanted. So we remove the print k. Let's just confirm that make run. So that print k, taking the print k out fixes it. Which maybe makes sense. Maybe. Like something in my gut is telling me that like what the fuck just happened? Something in my gut is telling me that the kernel doesn't know that it has to realign the stack or something. Right? Like I think that if I put like int val equals this and then I print another time, like does that change anything? Still seg faults. Yeah, there's just something about this call. Like according to according to this thing you sent me that says that the stack frame should be 16 byte aligned. And the fact that it's not 16 byte aligned directly when we call this, it's like, I wonder if it just like doesn't know. I wonder if this warning that's saying, no, this warning is not related. I was saying that these ones that say like there's no previous prototype, like maybe it doesn't know that it's like an external function. Right, like it feels to me like if we breakpoint like literally right here. Did you already set red zone false in the build zig? I think so. Yeah, right here. Right here. I wonder if this is maybe a problem. I was just kind of like hucking shit at the wall earlier to be like, I like just try to get like it to get rid of the EH frame stuff. I wonder if like one side is expecting a frame pointer and the other side is not. No, okay. That's good, I guess. Yeah, maybe don't omit the frame pointer LMAO. Yeah, I mean, it seems we could just kind of do this and see what happens. I again don't think this will fix it. Really, there's something strange to me about the fact that like literally when we call the function, it's like immediately fucked like right at the C ABI boundary. You know what I mean? My suspicion is the length of the strings is being done by pass by value instead of on the stack as a pointer. But like, shouldn't they agree on the calling convention? Okay, let's we could look at the disassembly. Okay, let's rebuild. Okay, let's rebuild, and we will copy the kernel module here. We will run with GDB, which means that we have to type -s here. Okay. Then we will type gdb-x here and continue. This segfaults. We breakpoint here, and then we say lx symbols to force it to load the kernel module. We say break on dev regex impl set regex. Okay, and we also break on dev regex or regex ioctl. Continue, and we run this again. Test. Okay, so here They should agree on the call conf. Yes. I've only been half paying attention to your debugging if it's mine showing me the stack element call. Yeah, sure. Give me 1 sec. 1 sec. 1 sec. So here at the beginning of the ioctl, I see 16-byte aligned stack pointer. Great. Now, I think that what's fucking us here is that when I continue, we're right at the start of the zig side of things. We have a stack pointer that is 8-byte aligned instead of 16-byte aligned. And this just propagates all the way down, right? If we, I think, how do we get there? Hold on, I need to find the function. 1 sec. Dev regex impl.zig. So we are going into alloc, raw alloc. We're getting to here. So if I breakpoint here and I hit continue, and we hit, oh, the alignment requirement is before the call, so if it pushes the return address, you'll get offset by 5 points. Okay, well, then there's still something wrong, though, because here, if we look at disassemble, we see this is the instruction that's failing. This move apps xmm0 to this, right? And we're seeing that it's going 70 off the base pointer, and if we info registers here, our base pointer RBP 8-byte aligned, right? So it makes sense that it's crashing there, right? It's like all the way down. It's just like propagating. To me, it seemed like it was just propagating this like 8-byte alignment all the way down. That's kind of what I was thinking when I saw that. Is it still 8-byte aligned with the val equals 0 print? No, I'm pretty sure that fixes it. We can double check that. We can double check that. So I'm pretty sure when we fix it, pretty sure that it fixed it because it's 8-byte aligned. So here we did like a, it was this. It was int val equals 0 and then print k px address of val. This is what we had to fix it. So let's just confirm that we do all of our debugging steps again. Quit cp for copy and run.gdb. Continue. Right, so this fixes it. Okay, and then we breakpoint on that same thing. LX symbols, break here, continue, run our test script. We need to make sure that we are doing it from the context of the ioctl. So that's not this one, not this one, not this one. Oh, sorry, it was that one. I just can't fucking read. CC backtrace. So here we are now in set regex, and if we look at the registers, we see RBP 0-byte aligned. Right? So like someone's not agreeing. Someone's not agreeing. Although Mlug is saying that like if the requirement is before the call, so if the call itself pushes return address, you'll get offset by 8 bytes, which seems maybe reasonable, maybe. But like it does seem like the whole way down the zig stack we're 8 bytes off. That's just kind of how it feels to me. Can I like C for stack alignment function call? Yeah. Okay, is there like an attribute? Like function attribute? Meep map. Right, so that's quite kind of why I was looking at here. Breakpointing at this thing. But we need to breakpoint there at the broken case. So let's go back to getting rid of this. Make, run, quit, copy, GDB, continue, break, LX symbols, breakpoint here, continue. Right? Like, what the fuck? Oh, it's 74. Maybe is the problem here. 74. So my confusion here. I should note that within the Zig stack, it may not obey the calling convention. Zig may use a faster. Yeah. I've seen that. I've seen that. But it just seems like to me that like Zig is assuming that at the top level, like it just seems like if it's off by 8 at the beginning, then it propagates all the way down. It just feels like there is a misunderstanding at the calling convention boundary. It just is where it makes most sense to me. I don't know if that's like I'm really going off like poor knowledge, right? So, bear with me. But here, I wanted to look at right before the call, right? So we step instruction. We're trying to get to 3.6. 2F. So here the stack pointer is already where it's going to be when we call, right? Right? Like, and if we info registers, like it's 8-byte aligned, right? So if Zig is assuming 16-byte alignment at the call site, it's just not true. You know what I mean? Like, because we're about to fucking call. Which makes me think we should fucking look at the kernel flags. Right? We should just look at the fucking kernel build flags. And we can do that. We can just echo C flags right here. Stack. Align. Dash, okay. This looks promising. Unless, like, maybe you have to pass this. No, that's probably not it. F-align functions might be, like, the function alignment pointers. Like, that might be, like, where the functions themselves are, not the stack as it goes in. I'm just getting, like... Sorry, blue or black. You've been talking about that struct alignment. I just don't see why it would matter. I don't see why it matter. Preferred stack boundary? Maybe. How come when I search stack here, by the way, it like doesn't find it? Can we do like test text? Stack. F no stack protector, no stack. What's F conserve? F no stack check and conserve stack. Conserve stack sounds sketchy to me. Attempt to minimize stack usage. The compiler attempts to use less stack space even if that makes the program slower. This option implies setting the large stack frame and large stack frame growth. While blah 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 blah, growth of large stack frames. Yes. Do the set align stack thing. I think that M preferred stack boundary is totally it. Let's see. Preferred stack boundary. 2 to the 3. Yeah, that's fucking it. That's fucking it. So you're saying set align stack thing in Zig? Does that make sense? Can I ask Zig to do 8-byte stack boundaries instead? I would rather match it up. But maybe not. Maybe we just say at every entry point we just have to type set align stack. That's not crazy. So here we could do that on every exported function, we set align stack to 16, and we just fucking like slap this on everything. And let's try that. Let's kind of fuck. Everything's broken. Everything's always broken. Where the fuck am I? Foreground run.sh -s. Get the fuck out of here. Run.sh. Fuck. Test run.sh. I fucking just did this. I don't know where it went, but you know, whatever. Everything's fucked up when I have like broken. Fuck. Really, that wasn't it. That wasn't it. I guess maybe set align stack might assume something that is untrue. I think the kernel's overriding this because generally kernel code disallows SSE and stuff, so they probably don't need 16-byte alignment. That seems likely to me. It would be interesting to see if this set align stack actually does anything. I wonder if like, can I, like, is there like a Zig build option that lets me do the same thing? Zig, like, can I look at -m here? What it was like stack alignment, M stack alignment, which does exist for Zig CC. I should probably disable SSE, MMX, etc. in Zig. I want to see if like I can get the same trick though, where like Zig just knows. There's a reason they disable it to do with register preservation. Oh, okay. I'll accept that. But first, I want to fix this one specific issue first. You know? But maybe that's not an option. I don't really understand why. I don't really understand why setting set align stack didn't help, to be honest. I mean, we could also, we could disable that build argument in C, or in the C side. Was it preferred stack size? Where does this come from? Like, can we just like disable this shit? For GCC stack alignment specified with M preferred stack alignment, Clang has the option M stack alignment for that purpose. Okay, but like, can I just not do this? By default, have 16 bytes for x86. However, the standard kernel entry on x86 leaves a stack on an 8-byte boundary. If the compiler isn't informed about the actual alignment, it will generate extra alignment instructions for the default alignment, which can keep the stack misaligned. Okay, so I shouldn't turn it off. I suspect set align stack isn't working because it already goes, well, it's already 6-byte aligned. Yeah, that's kind of my assumption too. That's my assumption too. That's why I was looking for a way to tell it that it's not that way. So if I like zig build obj, is there like, yeah, it doesn't look like I have like the tools I need to set that alignment. But like this claim in the kernel docs, there was mstack alignment. That was on Zig CC, but not on Zig build obj. So this really makes it sound like it shouldn't work. You know what I mean? Like it seems like we have to do it, because he's kind of saying like, when I'm assuming standard kernel entry means like the entry point into the kernel, and so the compiler needs to know. It'll generate extra alignment instructions for the default alignment, which can keep the stack misaligned. Whoever said try set stack align 8, that seems like not unreasonable, right? It seems like that might kick Zig into then knowing when he calls the next function to undo it. Unless it doesn't like, unless he still goes like, I'm already 16-byte aligned, I don't have to do jack shit. But I'm down to try it. I'm down to try it. Yeah, it's probably just doing jack shit. Can I do it just like on the C side? Maybe here? Here I just have to, before I call it, can I like force stack alignment clang or GCC built in or something? Like there's got to be some way like GCC set stack alignment. Like I just want to like, I guess we could do something like macro or like define call zig function. How do you do this again? It's something like, how do you do the like propagate returns? It's something like this where you put like the double things, like the macro double thing to like propagate the return or something. There's like some, I just like fucking didn't speak English there for like fucking 15 seconds. Linux C macro propagate return. I know that they do this all over the place. GCC has this extension that says if you put a circle, a parentheses, then a bracket, then you can just put the thing as the last item. So I wonder if we can do like call zig function uint64t elem, right? Just like fucking force the alignment. You know what I mean? And then like, then just call f. How do you do like, I guess just this, right? Right? And then we can do like here. Fuck. Reset. Here we can do, what is it complaining about here? I don't really understand. Oh, this has to be like this. I forgot. Macros, you know, stupid shit. You know, like, does this force? I don't know if this is enough to, if it's gonna like optimize that out. So can we also like, no, we'll see. Run. Still seg faults, right? But if we printf the elem, in C, if you have f, that just returns the point of the function f. No, because I'm putting the brackets inside. So what happens here is the preprocessor takes everything in the brackets and puts it after whatever I placed here. So this is actually putting the function call down here at preprocessor time. So that's intentional. Let's do px and lm like we did before. This should be kprintf. Print. Is it kprintf? Print k. Sorry. Fucking brain. Then run. Yeah. Okay. So there's definitely a fix here that we could do on the C side, where just like every time we go through the like C zig API, we just force 16-byte alignment. And here I've done it by like just putting a thing on the stack that has to be 16-byte aligned right before. And there's something there. I'll have to do some research. And I'm really short on time. I'm actually late for something. So that's okay though. I had a lot of, this was really fun. Really fun. Thanks for watching, guys. Use self-corruption. Try putting attribute force align arg pointer on your C entry points. I will write that down, but I'm not going to do that right this second because I'm really late for something. Something I organized. So I like my friends are going to be so pissed at me. But thank you for watching, guys. I had a lot of fun today. This is the type of shit that's like, who hits this? no one, right? It's like, what's happening? Like, but it's fun anyway, either way. So thanks for watching. If you like what you saw, we stream most days at around 12:30 Pacific time. We try to go to 4 Pacific time. It's 5 Pacific time now because this was too fun. We couldn't stop ourselves. Yeah, if you like what you saw and you're watching on Twitch, there's a YouTube link in the Twitch description where you can swing by and check out our previous projects. We're working on this like dev regex kernel module right now, but like this is a short-lived thing. Supposedly, it was supposed to end today. It won't end today because we didn't do anything. But you know, it was supposed to end today. But we'll go back to the map soon. There's like a operating system in here, like QR code decoder, like Rube Goldberg machine, video editor. You know, if you want to check that out, that's there. What else? If you're watching on YouTube, there's a Twitch link in the YouTube description. You just swing by and say hi if you're online. You will notice if you're watching on YouTube that this video is not 12:30 to 5 o'clock long. It's because there's a pre-stream segment. We call it happy hour, where we kind of just hang out and like do like bug fixing and lower priority stuff and like hang out and listen to music and stuff. So today we were working on fixing some of the rendering issues with the native OpenGL app in the map. So if you want to swing by or check out the archives on Patreon, those are available. Like, subscribe, Twitch Prime, you guys know the deal. And let's say goodbye to YouTube and Twitch. Let's find someone to raid.